Hello students. In this lesson, we are going to learn a bit more about correlation. More particularly, we're going to understand the difference between correlation and causation. They're two similar things, and since we have learned about correlation, we need to emphasize a bit more on it. So let's get to it, starting with the prior knowledge. Use your calculator to find a line of best fit and correlation coefficient for the data. Basically, a review for things we have learned yesterday. So here is the calculator. Let's go through the process. I have reset the calculator already. So first, we need to click on mode to make sure that stat diagnostics is actually turned on. Right now it is turned off. So I need to move it on to on, enter, now it's turned on. Go back to the normal screen. Then starting typing the data, stat, edit, and I'm going to type X into the first list. 3, 5, 6, 7, 9, 11, 12, 14, and 17. I'm going to type the numbers into the second list for Y. 3, 4, 6, 8, 8, 13, 11, 14, and 16. Then I'm going to click Stat, but this time go to Calc, and then we're going to choose Linear Reg. Make sure the X list is L1 and the list for Y is L2. So enter, 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 enter until it's calculate, enter again. Now we have our A, B, and R. Our A in this question is going to be 0.97 after running to 2 decimal places. Our B is 0.15. That means our equation is going to be Y equals 0.97x plus 0.15. As for R, round to 2 decimal places, 0.97. Quite close to 1, so it is going to be a strong positive correlation. That is the prior knowledge. Now let's move on to the actual lesson for today. First, the definition for correlation. Correlation, in other words, association. It means there is a relationship or pattern between the changes in one variable and the changes in another variable. Just saying two things, one is increasing, the other is increasing, they might be related. So we need to explore more to actually understand the relationship. Next, causation. It is a change in one variable causes a change in another variable. Causation is the cause and effect relationship between two variables. For example, there is a positive association between ice cream sales and miles driven. That just means when you actually calculate out the data, you see the points, seems they have a pretty strong correlation, so they could be related. However, does this mean ice cream sales cause more miles to be driven? Of course not, because these are two, I mean, in our pure logic, these two things doesn't sound like they don't sound like they're related. So ice cream sale may be a very special case. There's an ice cream shop far away that they're gonna close pretty soon, and you want to support their business, so you decide to drive a bit more to actually buy more of ice cream. Maybe, but that's a very rare case. So in reality, ice cream sale does not cause more miles to be driven. Moving on, here's some more examples to about correlation, and is asking you to explain why they are correlation but not causation. The grade point average or GPA for a student is lower the more days a student is absent from school. The low GPA did not cause the student to be absent. In fact, if the student is absent, they might be absent because they are sick or there's some family things they are going through. These could be the reasons, not because they have a low GPA. Suddenly they're like, I have a low GPA, so I'm going to stay home. Not quite. Also, absences do not cause a low GPA. When students are absent, they do tend to have missing work they need to complete, but they're not making it up. So not making up the missing work actually does cause a low GPA. But absence, sure, it could cause some potential missing work, but if you make it up and you actually learn the lesson, then you'll be fine. So both ways, they're not causation, they're not causes of each other, so they're just correlations. Next, the vocabulary level of a person is higher when a person's height increases. Well, even if, let's say, you are growing older, sure, it seems like your vocabulary is getting higher, but it does not necessarily mean it's going to always be the case. Being tall does not cause someone to have a high vocabulary level. If you think about the students in our class, Does that mean whoever is the tallest will have the most vocabulary? Probably not. That's not the case. It's because these two things, maybe they are related because of the data, but they are not causes for each other. Moving on, example 2. So this one, 1 week in the month of June, the number of new babies born at the Utah Valley Hospital were recorded. That same week, the number of cakes sold at a bakery in Hoboken, New Jersey were also recorded. Find the line regression and describe the correlation. Then determine if the scenario is causation or correlation. So first, we need the data to be in our calculator. There's our calculator again. Let's go through the process. So stat. This time, let's actually clear the list first. Go up, clear, enter. Now list 2 is gone. Go up to L1, clear, enter. L1 is gone. Now let's type in the new data that we need. 5, 7, 9, 10. Oops. Didn't type it correctly. Let's try it again. 5, 7, 9, 10, 11, 12. 25, 30, 35, 42, 48, 52, and 56. There we go. And stat, we're going to choose calc 4, then rec, click enter, 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 enter. Calculate. We will get our A to be 4.48. Our B is going to be negative 0.47. So our equation is y equals 4.48x minus 0.47. Our R is going to be 0.96, which means we have yet another strong positive correlation. The question is also asking you to graph the regression line. We're just going to do it roughly. We'll estimate this number to be 4.5 and that number to be at negative 0.5. So negative 0.5 is the y-intercept. It's around here. 4.5 means move up 4.5 over 1, so it's going to get to 1, 4. Close. And then up 4.5, so it's going to get to 8.5-ish. At 2, up 4.5 is going to get to 13. So now I can connect. And there we go. That's our line. It's not the most precise, but you get the idea. So because after we calculate the R, we see a very strong positive correlation, means the new baby born and the cake sold seems they are strongly related. So that means we can come up with a causation statement. Therefore, an increase in the number of babies born at Utah Valley Hospital causes the number of cakes sold at Carlo's Bakery to increase. Is that true or false? By simple logic, clearly that is false. It's not like every single family that has a baby at Utah Valley Hospital, afterwards they're going to fly to New Jersey and buy a cake at this bakery. Or they're going to suddenly order cakes from this famous bakery. Most likely not, because these two places are far away, and one does not cause, having a baby at Utah Valley Hospital does not cause the number to actually increase, because they are not actually related. Maybe if you have a cake shop next to the hospital, next to the Utah Valley Hospital, there could be some causation there, but not in this case. So now let's just practice a bit more on identifying the correlation and causation. Decide on the correlation if the causation statements are true or not. Mr. Price gave a math test to all students in 7th grade. He discovered that the taller students did better than the shorter ones. Taller, better, which means increasing. So it's going to be a positive correlation. Causation statement, therefore, an increase in height causes math ability to increase. Of course that is false. It's not always going to be the case that the tallest student in the class has the highest math ability or highest grades. No, not necessarily at all. So we can say, as for the explain, as long as you can explain the reasons clearly, there's not one right way to say this. Basically, height doesn't cause high math ability. For later ones, I'm not gonna write all of these. You can just listen to. I will actually say and explain it in words. B. Your mom noticed that when she reads her emails, her children ask for snacks. Therefore, moms reading emails cause children to need snacks. While reading email more frequently, needing for snacks more frequently, so clearly that's a positive correlation, but it is still a false statement. The causation is going to be after the word therefore. That's why I highlighted that word. It is false, but you may argue, wait, but I mean, it's because the moms are reading their emails, so the kids want their attention, so they're trying to get snacks from the mom. Well, maybe, but you could also have a lot of other ways to get attention. So this may not always be true. So not necessarily the actual cause. So that is question B. C. Mr. Yao loves to ski. He learned that the ski resort sells more hot chocolate on cold, snowy days. Is this a positive, negative, or no correlation? Cold days, when you have more cold days, then you sell more hot chocolate. So clearly, that's a positive correlation. Do cold, snowy day cause people to buy hot chocolate? Yes, it does, because people want to stay warm. So hot chocolate helps them to stay warm, and that's typically the case. So that's question C. D. The more meals you eat out, the more money you spend at restaurants. Is this positive? More and more. So clearly that is going to be positive. Is there causation? Yes, because you spent money when eating out. So that means the more you eat out, the more money you will spend. But maybe a very unlikely case that your family owns a restaurant, and whenever you eat out at your own restaurant, you're not spending money. So that could be the case, but a very rare situation. So in general, logic-wise, we're gonna say it is true. There is a causation there. Next, E. Time in the sun with unprotected skin and risk of sunburn. Causation statement: exposure to sun causes sunburn. The longer you expose yourself, the more severe sunburns are. So positive correlation, and that is true because that's literally what sunburn means. It's like putting yourself under the sun. So if you expose enough, then of course you're going to get sunburn. F. As vehicle weight decreases, fuel efficiency increases. Causation statement: therefore, vehicle weight determines fuel efficiency. First, when it's decreasing, the other increases, so clearly they're going to opposite directions. That's going to be negative. As for the statement, you could actually argue for true or false in this case. If you want to argue it is true, well, it does affect the vehicle weight. Let me rewrite it. Weight does affect fuel efficiency. And typically, the heavier the car, for example, like if you drive the same car, but you have more people sitting in the car, you are going to notice the fuel efficiency actually changes. But you can also argue it is false because vehicle weight is not a major factor that actually affects. It could potentially affect, but things like, for example, engine size. If you have a V6 versus a V4 or a V8 versus a V4, of course, the fuel efficiency is going to change. So you can argue both ways, as long as you can explain what you choose to believe. And that's the simple lesson. We're just identifying the causation and correlation, try to understand their differences. So there we go. That's everything for this lesson. Thank you.